Good morning, everyone. I'm excited to be here. TABConf is awesome. It's a great pleasure to be able to speak here. And originally, I wanted to give a very technical talk, but then I thought, actually what's most exciting to me about Bitcoin is the political dimension of it. So I wanted to emphasize that a bit more, and that's why I'm talking about making Bitcoin cypherpunk again. First of all, the future of money is probably one of the most important topics of society. And mankind is kind of at a fork in the road. Technology has advanced to a point where we can have two futures, a very utopian future where Bitcoin is widely used as a means of exchange and as a money. Or we could slip into a future where a pretty dystopian form of money, in particular central bank digital currencies, could be established, and that could be, as I said, quite dystopian. And this dystopian future, it will look like pretty dark. The general manager of the Bank for International Settlements, he says very clearly, the central bank will have absolute control over the use of this central bank digital currency. And of course, people who understand what that means say very clearly, just like Edward Snowden, that these CBDCs are crypto-fascist currencies. So people are advertising them as like a better means of exchange, but actually it's just crypto-fascism. And how does that look like exactly? Well, the central bank has absolute control over, first of all, the value of your money. They can devalue your money at any point. They can have negative interest rates if they want to. They can decide where you can spend your money. For example, there are ideas that your money is only spendable within a radius of, let's say, 20 miles around your home. And after that radius, your money is just worthless. They can decide when you can spend your money. For example, they can say there is an expiration date and you have to spend your money until the end of the year. Afterwards, it just becomes worthless. And they can also decide for what you can spend your money. So, for example, if they think you have bought a bit too much meat this week, then they can say, yeah, you're not allowed to buy any more wheat. Any more meat. Freudian slip. You're not allowed to buy any more meat, and you should eat other things. And of course, this is a form of central control that is probably pretty unhealthy, and it's right out a form of tyranny, and we should totally prevent that. And Bitcoin in this world, as the president of the Central Bank of Europe says, there needs to be a crackdown, a global crackdown, because if there's any escape, then that escape will be used, of course. So Bitcoin would have to be crippled down to become a custodial asset, and then we would essentially have digital energy that is held in custody by Coinbase, and of course nobody would be able to use it as a money. And that is of course the exact opposite of the utopian future that Satoshi drew back then when he created Bitcoin. Because if we look at the Bitcoin white paper, we can see here clearly in the title it's a peer-to-peer electronic cash system. There's nothing about digital energy here or something. It's nothing about custodial. Actually, it's the exact opposite. It says it's for online payments to be sent directly to each other without going through a financial institution. That is the main point of it. And if there would be a trusted party in between the people, then the main benefits of that system would be lost. So this idea of Bitcoin being held mainly by Coinbase is pretty much the exact opposite of what Bitcoin actually should be and is. And Bitcoin as a peer-to-peer electronic cash system has all kinds of nice features that I want to emphasize. I'm pretty sure you all know them, but I think it's worth mentioning them again. Bitcoin is first and foremost permissionless. It is completely self-custodial. It provides this nice feature of absolute scarcity. And ideally, it's private. Of course, there's a little question mark about it because it's not really private in its current form, but ideally, electronic cash should be as private as possible. And we should thrive for making Bitcoin more private. And this gives us, as the end user, a nice feature because you, as the end user, you have absolute control over sustaining the value of your money, sustaining your purchasing power. You can decide where you can spend your money. You can decide when you spend your money and for what you spend your money. And that is real self-sovereignty, and that is freedom as it should be. However, Bitcoin isn't perfect yet. Bitcoin isn't widely used as a currency, and that has many reasons, and I want to talk about the technical reasons behind that and how we can improve Bitcoin to be better suited to be used as money. The main unresolved problems, there are three. First of all, the scalability. The throughput of Bitcoin is quite limited. Currently, it can process roughly 7 transactions per second. Of course, we have the Lightning Network, but unfortunately, it doesn't work quite as well for end users as we would like it to work for end users. Then privacy is another big topic. We all know about these chain analysis companies and stuff like that that can essentially track users to a concerning degree. And lastly, the usability of the system is extremely important. It has to be usable to end users. It should ideally be as simple as Venmo or these established payment systems. However, this is beyond the scope of this talk. I will talk about scalability and privacy today. Make Bitcoin cypherpunk again. The two solutions that I'm most excited about are first BitVM, which is a way to bridge Bitcoin to second layers. And second, zkCoins, which is a way to improve scalability and provide strong privacy. And I'm going to talk about these two things now. First of all, BitVM is a way to build better Bitcoin bridges. We already have some kind of Bitcoin bridges, but they are essentially multi-sigs. And it's essentially you're giving your money to like a consortium of people, and then you trust them that they don't run away with your money. And that is, of course, not a very satisfying state of affairs, so we would like to improve on that. And BitVM is a way to make, attempt to have better bridges that have better security guarantees. Of course, it's about bridging Bitcoin to second layers, as I said, and ideally that would enable a free market of second layers. So everybody can create a second layer and make an offer to the market and see what sticks. And that includes sidechains, rollups. As I said, zkCoins is another second layer. And this ideally would create would enable an environment for cheap experimentation and rapid innovation, which is currently, of course, hard on Bitcoin because Bitcoin is so hard to change. And it's hard to innovate on Bitcoin because it is so stable in the end as well. So it's like both good and bad that Bitcoin is that stable. It's good for the currency in itself. It creates trust in the currency, but on the other hand, for innovation, it's not as good. But if we would have such a second layer, or like if we would have a free market of second layers, then people could just try out all kinds of interesting ideas and see and explore the solution space. And of course, ideally, that would enable both way better scalability and way better privacy. Those are the goals that people would probably optimize for. And what BitVM improves on is this trust assumption. As I said, currently we mainly have these multi-sigs where you have, like, let's say, 10 people and 7 of them have to be honest that this works, otherwise the money gets stuck or stolen. And here in BitVM, we can improve on that to like a 1 of n assumption. So you have a trusted setup, and let's say 100 people can participate in that setup, maybe even 1,000. And if a single person is honest in that trusted setup and deletes their keys at the end of the setup, then it's guaranteed that nobody can steal money. So there is a drastic improvement over existing bridges. The key limitations of Bitcoin, of BitVM, as I mentioned, it still requires a trusted setup. Ideally, we would have a system that requires no trust at all. But yeah, this trust assumption is still better than what we have so far, and it's vastly better, I would argue. A bigger problem, I would say, is the complexity of BitVM. BitVM is like a clunky workaround to enable things that we would actually like to enable by soft forks. And these workarounds, they introduce all kinds of complexity, and complexity is the enemy of security. And that's why this is definitely a drawback of BitVM, and hopefully in the long run we will find better solutions than BitVM. And the third thing is that the capital costs are relatively high. We need like liquidity providers who run these bridges, and they have to have a certain amount of capital that they have to put up as a collateral such that you can slash them if they misbehave. And most end users will probably not be able to afford that. So it will be liquidity providers similar as in the Lightning Network. Potential consensus changes that could improve bridges significantly. First of all, covenant opcodes such as introspection opcodes or TX hash, they would help a lot with that trusted setup. They could essentially remove that trusted setup, and then we would have essentially unconditional safety. That means nobody can steal money irregardless of the setup. The other thing is multiplication. Bitcoin script is incredibly limited, hard to understand actually, but we only have addition. We cannot even do a multiplication. To do multiplication, we have to emulate multiplication by adding a lot of additions, or like by having lots of additions, and that is quite expensive. That is also where this capital constraint comes from. And ideally, we would even have large integer arithmetic so that we could just multiply and add large numbers in a single opcode. And that would drastically improve these bridges and make it essentially trivial to run them, and the cost would be very low then. And with these, we would have much more secure and much cheaper bridges. However, I should emphasize again, currently BitVM doesn't require any soft fork at all. Like, it works out of the box as Bitcoin is today. If you want to learn more about it, I'm not being very technical here, but you can go to bitvm.org. There's also a talk that I gave this year at the MIT Bitcoin Expo, where I really went into the nitty-gritty and explained like all of the details of the protocol. The second thing I wanted to talk about is zkCoins, which is a second layer that is in particular for payments. And the idea is that it can drastically improve the scalability and in particular the privacy. And zkCoins is based on a couple of design principles for, in general, blockchain scalability, I would say. And the first idea is that we should never write into the blockchain what can be communicated off-chain. That is because, of course, blockchain space is expensive, it's scarce, and we should really think about how can we optimize transactions such that we only put into the blockchain what really needs to be there, and everything else should be communicated off-chain ideally. The second design principle is to avoid any kinds of validation on the global layer that can be performed on the client side. I will explain more in detail what that means, but in general, the idea is that on the main layer, everybody has to verify everything, and that scales poorly. If everybody on Earth has to verify all transactions of all other people, that is, of course, a lot of overhead, and that's why we should try to minimize the amount of validation that is required on the main layer. And client-side validation is an approach that fits these design principles very well. Maybe you've heard of it. It's essentially what RGB is, or Taproot Assets by Lightning Labs. And the key idea behind it is that if I send you a coin, then you as the recipient, you are incentivized to verify that this coin is actually valid, that this coin followed the consensus rules, and that makes it a valid coin. Because if that is true, if I can convince you that this coin followed the consensus rules, then you can accept it and you can convince the next person that this is a valid coin. And if I send you some rubbish that didn't quite follow the consensus rules, you just ignore it. It's just the same as if I hadn't sent you any money at all. And this coin history, I can communicate it off-chain to you. I can just send it to you in like off-band. It doesn't have to be in the blockchain. And that's the key idea behind client-side validation. And what we need the blockchain for is actually just to prevent double spending. I can prove to you that this coin followed all the consensus rules, and you can verify that. The only thing you cannot verify without a third party is that I didn't send that same coin to someone else. And that's what we need the blockchain for. We need the blockchain to ensure that I sent this coin only once to someone else and not twice. And it's quite interesting that this is really the only thing that we need the blockchain for. The blockchain doesn't have to verify the history at all, because you as the recipient, you can verify it. However, historically, the fundamental problem of all these client-side validation protocols was that these coin histories grow quasi-exponentially. They grow quite quickly. That is just because it's like a tree of transaction that are the ancestors of every coin. And yeah, that grows quite quickly. And of course, if I'm at the supermarket and I first have to transfer 2 gigabytes of data to the cashier, it becomes quite absurd. So the key idea here behind zkCoins is that we use these awesome advancements in the field of zero-knowledge proofs to compress these coin histories to a negligible size. And that's quite awesome, actually. Then the coin history becomes so small that I can send it to you in a text message. And no matter how old the coin is, no matter how long the history is, the coin proof still is always succinct. And this entire problem of the growth of the history is completely solved. And as a nice byproduct of that, we also get privacy for free, because by compressing away this entire history and by wrapping it into this zero-knowledge proof, we can essentially obfuscate all the data. And yeah, that brings us to the idea of zkCoins, and the key features of zkCoins are, first of all, it can increase the throughput of the base layer to more than 100 transactions per second. So it gives us roughly 10 to 20x more throughput on the base layer. The second, I already mentioned it, it gives us strong privacy. It obfuscates both the transaction amount and also the graphs. And yeah, that results in privacy similar to Zcash or other protocols. It's essentially top-notch privacy, I would argue. And the cool thing is it requires no consensus rules at all. We need the blockchain only to inscribe very small commitments, and everything else happens off-chain. And yeah, that makes it quite a nice fit for Bitcoin, because as I mentioned, Bitcoin is hard to change. So we actually want to have solutions that don't require many changes. And even more awesome is that it doesn't bloat Bitcoin's UTXO set. zkCoins is completely decoupled from Bitcoin's UTXO set. We need the blockchain actually just to inscribe these commitments. And even if we had 1 billion zkCoins users, the UTXO set would grow not at all. And that is a big thing, because the growth of the UTXO set is quite a concern in Bitcoin. Yeah, because essentially miners have to have it in memory to be able to validate blocks quickly. And that is yeah, a main pain point actually of scaling Bitcoin, and that would be completely solved with approaches like zkCoins. And even more awesome is that it makes blocks faster to validate. Intuitively, you would think if a block contains way more transactions, then it becomes much harder to validate the block. But since we don't validate anything about these zkCoins transactions on the main layer, it becomes actually easier to validate a block. You just have to validate a couple of hashes. You don't have to validate any signatures at all. It becomes quite cheap to validate blocks. A block full of zkCoins transaction would be way easier to validate than a regular Bitcoin block. And ideally, zkCoins would also be compatible with the Lightning Network, which would increase the throughput, of course, even more. However, there's a little question mark. Currently, there is the trivial solution that we solve this by using more data, and that, of course, decreases the throughput. Then we wouldn't have this 100 transactions per second, but just a little bit less. And also, it would decrease the privacy, and it's an open research question how to have Lightning channels that are indistinguishable from regular transactions. The main limitations of zkCoins, well, you have to communicate these things off-chain, so you need some kind of communication channel between the sender and the recipient. However, it's not that bad. As we have seen in eCash, it's actually quite easy to use messengers like WhatsApp or Signal to just send these coins in a text message. And it's not that bad. The bigger problem is that backups are super crucial. Bitcoin users are actually used to the nice situation that you just need your seed, and as long as you have your seed, then you will always be able to recover your coins. Here in zkCoins, it's not the case. You need to have your coin proofs, and if you lose your coin proof, your money is gone, and it's absolutely impossible to recover it. So backups become super crucial. And the other thing is there is no global state. If you wanted to have like something like an automated market maker or some other sophisticated smart contracts, it's not quite possible on zkCoins without having way more on-chain data, which kind of defeats the original purpose. A rough overview of the history of client-side validation, just to give you an idea how that evolved. Already in 2013, Peter Todd described the idea of client-side validation. And back then, he already mentioned the idea of combining client-side validation with zero-knowledge proofs. However, back then, there wasn't really any practical instantiation of zero-knowledge proofs, so this idea went anywhere in 2013. And 2019, the RGB project was started, and they already added confidential transactions. In 2022, Taro was started. And in the same year, I published zkCoins with the hope of repopularizing the ideas of Peter Todd. And I also added a couple of other ideas to like modernize the ideas that Peter Todd had back in 2013. And finally, this year, together with Jonas Nick, who is sitting behind there, and Liam Egan, we wrote a paper called Shielded CSV, where we fleshed out all the ideas and all the missing parts that were missing in like that write-up that I had in zkCoins. zkCoins was like more a bit hand-wavy, to be honest. It was more like describing that the idea is possible these days, but it was like not practical. There was hardly any implementation, just a couple of rough ideas. So we thought, hey, let's make it a serious project now, and then we created Shielded CSV. And I totally recommend tomorrow, Jonas will give a talk about Shielded CSV, where he will go into the details of the protocol and explain all the nice nitty-gritty of it. It's tomorrow at 9 o'clock or something. It's tomorrow morning. Check it out on the website. Yeah, and potential consensus changes that would make zkCoins even more awesome. First of all, better bridges, just like BitVM. We have to bridge Bitcoin into the zkCoins protocol. So we need some kind of bridge. And if we had better bridges than BitVM, of course, zkCoins would have better security guarantees. And here, the bit controversial topic, block size increases could become interesting. Because since zkCoins don't bloat the UTXO set, and the validation of blocks become very cheap, there's hardly any argument against increasing the block size. So it could be interesting to think about that if something like zkCoins catches on. And even just a 2 times increase in block size would already surpass the throughput of PayPal. And it's quite an interesting idea to think about in my eyes. Summary and outlook. First of all, outlook. Hopefully, we will ship BitVM bridges by the end of this year. That's the goal of the so-called BitVM Alliance that we just founded. That would enable rollups and sidechains on Bitcoin, and hopefully would enable that free market of second layers and enabling all these nice things like rapid innovation and cheap experimentation. And hopefully, maybe some kind of zkCoins toy version by the end of next year. I don't want to promise too much, but I hope we can initialize some implementation of it. Oh, yeah, here's Jonas' talk tomorrow. Second recommendation. I think it's going to be great. And yeah, the summary of this talk. The future of money. Digital slave money is a serious threat. We should talk about it here in the Bitcoin community. We should be open about how dangerous CBDCs are. We should not sugarcoat it or something. It is definitely a tyrannical technology, and Bitcoin should be used as money. And first and foremost, it is freedom money. It is a counter. It is a way to counter these tyrannical ideas. And as I said, we are in this fork in the road. And to improve Bitcoin as cash, the two most exciting projects I know about currently are BitVM, which enables better bridges, and zkCoins, which enables better scalability and privacy. Here again, this is the situation that we are in, I think. And yeah, I'm very glad to be part of this community here of people who try to fix the money and fix the world. And yeah, I'm excited and I'm optimistic that we will go the right path, no, the left path. Okay, thank you.
If anyone has any questions, just raise your hand and I'll bring a mic over to you. Where? Over there.
Morning. Yeah, I got in a little late in the presentation, so excuse me if this is a stupid question, but like my understanding from talking to everyone that works on BitVM is that they just really don't want retail users to have to go through the bridge, right? Is shielded CSV, is there a reason why you couldn't do just like atomic swap, like out of the, I guess out of CSV, out of the shielded CSVs and into Bitcoin? Is that something you envision where you'd have like bolts type services just doing swaps in and out?
Yes, certainly. The idea behind these bridges is that a bit clunky is okay, because as long as that bridge works, you have a guarantee that this site system asset has actually value and it's actually backed by Bitcoin. And when something bad happens, you will always get your main chain Bitcoin back. And as long as that is guaranteed, then it makes sense for others to provide infrastructure to have atomic swaps for end users to essentially have instant settlement between the main layer or between even different layer 2s. And ideally, or like I envision a world where the Lightning Network becomes the central settlement layer between different layer 2s. And then every end user could just settle instantly with any other layer 2 or with the main chain without going through the bridge at all. But yeah, to guarantee that the sidechain asset has value, you will have the bridge. But it will be used rarely, I think. And that's okay. It's just to guarantee the value.
Any other questions? We have a couple minutes. All right.
Hi, could you describe a bit more for the shielded CSV what the zkP is verifying? Like, are clients maintaining a Merkle tree of all the commitments to these private coins?
These proofs, they verify essentially all the consensus rules that you have to follow that the coin is actually valid. A trivial thing is that you don't create money out of thin air. The inputs and outputs sum up. And yeah, it's essentially like, it's pretty much like Bitcoin itself. Like Bitcoin has all these rules that make a transaction valid or invalid. And all the things that make the transaction valid, they are encoded in that zkP. And the only thing that is not in that zkP is the double spending aspect, which is solved by looking at the chain. You cannot solve that in the zkP because it cannot tell you if a double spend occurred or not.
Anyone else? No? All right. Well, give everyone a round of applause.